Space junk enters Earth's atmosphere almost every day. Specialists from Earth track most of it. Around 400 such incidents happen every year, but not all space debris can be tracked. Some fragments of satellites may fall to the ground. That would give us meteor showers every night. Junk falling from the sky develops huge speed, which implies severe destruction. Fortunately, none of this really happens. Very few people had the chance to observe the falling space debris. There were almost no cases in history when fallen satellites damaged someone else's property. To find out what happens to space objects during the fall, you'd need to understand how they managed to fly around Earth for so long. Imagine you work for the Meteorological Service. Today, you're launching a satellite into Earth's orbit to monitor the climate of the planet. The satellite is installed on a rocket. The rocket takes off and reaches the speed of 25,000 miles per hour. This is faster than the speed of a bullet and the speed of sound. This acceleration is necessary for the satellite to overcome the gravitational attraction of the planet. As soon as the satellite goes into space, into the upper atmosphere, the rocket simply falls off. But it's given the satellite the necessary speed and energy to make its motion possible. This movement is called momentum. The satellite is located at an altitude of thousands of miles from Earth, but still, gravity pulls it down. Momentum and gravitational forces make the satellite fly in a circular trajectory around the planet. This trajectory is called an orbit. At this speed, the satellite could move further into outer space, but the force of gravity pulls it down. Our meteorological satellite is balancing between these two forces, and it's quite difficult to find this balance. The closer the satellite is to the planet, the stronger the effect of gravity. To stay in such an orbit, the satellite must fly very fast. Here's our satellite entering orbit and developing incredibly fast speed. And now you can see one of the reasons for its failure. Thousands of other space objects are flying past the satellite at the same speed. The slightest collision can lead to devastating consequences. Currently, about 500,000 pieces of space junk are flying around Earth. These can be small pieces, the size of a tennis ball, or huge ones, the size of a subway car or a bus. There are also tiny fragments of satellites. If two pieces of spacecraft collide with each other, they fly apart into thousands of small segments. The number of them can reach up to 170 million. The planet's orbit is filled with unnecessary debris rushing at great speed. Most of them are tiny, the size of a grain of sugar, but they are no less destructive than the decommissioned segments of rockets that deliver satellites into orbit. For example, a single drop of paint can damage a spacecraft if it's flying at 30,000 miles per hour. To avoid this, engineers calculate the routes of satellites they launch in advance. They also cover it with a strong protective layer of various metals. The more orbital debris flies around the planet, the more accidents happen. And the more accidents happen, the more orbital junk appears. This is an endless circle. But scientists try to develop strategies to clean up Earth's orbit. The next cause of accidents is the Sun. Our star is constantly releasing high-energy particles. These particles collide with everything that gets in their way. And when they crash into satellites, they can change their trajectory and slow down momentum. There's a shield in the upper layers of the atmosphere, the Earth's magnetic field. Satellites fly inside this shield. The field reflects solar radiation from the planet, but there are places on Earth where this shield is weaker, and when satellites fly past such spots, they receive a large amount of radiation. It disables navigation and the stable operation of all systems. Fortunately, accidents caused by solar radiation are rare. Another reason is the change in the gravitational field of Earth. Our planet is in motion. Its internal processes can change the shape of the gravitational field. These changes can disrupt the satellite's flight path around the orbit. Fortunately, such gravity failures are insignificant. They can only cause the satellite to fall after a few years. And the most important reason why satellites fall is people disconnecting them. If a satellite can no longer transmit data or is outdated, specialists simply make it fall. Another common reason is the lack of fuel. If the satellite runs out of it, it's impossible to control it. It turns into a senselessly flying object. That's why experts use the remaining fuel to slow down the satellite and bring it out of orbit. Scientists plan such operations well. They stop the satellite at a certain moment so it can fall over deserted areas of the oceans. The satellite falls and passes through Earth's atmosphere at great speed. The lower layers create strong pressure and friction on space junk. These processes generate a huge amount of heat. The satellite catches fire and falls apart. Most of it simply burns. The remaining debris falls in remote places of the planet. This method works when the satellite is flying close to Earth. Some space objects are located far from the planet. The Earth's magnetic field is much weaker there. In such cases, it's easier to use the remaining fuel to go beyond the gravitational force. They just send a satellite to float into outer space. Pieces of rockets, large metal remnants of old satellites, and other debris can't be controlled. All these pieces fall into the atmosphere of the planet and turn into ash. The smaller the falling object is, the fewer chances it has to reach the ground. Big junk can survive in the atmosphere. Fortunately, such objects are monitored by special services. When an old satellite enters Earth's orbit, people already know in advance where it will land. And if someone is in this territory, they will be evacuated. But this happens quite rarely. People only use a small percentage of the total land area for living. More than 70% of the planet is covered with water. If the atmosphere can't burn space debris, then water will destroy it. Space objects either fall into the ocean or in sparsely populated areas of Earth. The probability of a satellite hitting someone's house is really small. But if that happens, then, according to the law, the house owner will be compensated for the damage. Whatever country you live in, the company that built the fallen satellite will be to blame. This company is obliged to pay all losses. Falling space junk has its favorite location on our planet. This place is even called the Satellite Cemetery. Point Nemo is a conditional spot in the world ocean, the most distance from any land on Earth. It's very difficult to get there, and it's not much easier to get out. If you find yourself in this place, you need to sail more than 1,000 miles to get to the nearest island. Moreover, the distance to the International Space Station from this place is smaller than to the nearest land. If you suddenly find yourself on a ship at Point Nemo and you run out of fuel and don't have a radio, then you need to think about what signal to send to the sky. Astronauts from the ISS may notice you and inform the Coast Guard of your location. Almost no ships sail here. That's why all companies throw their satellites away in this place. The blast wave, the force of the impact from the junk, will dissolve in the boundless ocean. The bottom of this place is covered with space debris. Falling satellites do no harm to sea creatures. Point Nemo is one of the most lifeless places in the world. Cold, nutrient-rich water doesn't get here. There's hardly any wind that's carrying a lot of organic substances through the ocean. In simple words, there's no necessary amount of food for the development of large life forms. Right now, satellites are falling in Point Nemo and slowly sinking to the seabed.
In 1859, British astronomer Richard Carrington observed a peculiar solar phenomenon. Two bright patches of light on the sun, marking the discovery of the Carrington event, the most massive solar storm ever recorded. This was a time before the invention of the light bulb, a period of burgeoning scientific discovery. This event led to unprecedented auroras, visible from the equator to the poles, so vibrant that in some places like Missouri, nighttime felt like daytime. The sun's intense activity caused more than just stunning lights. The surge in electricity disrupted telegraph lines. with telegraph machines in Paris spewing sparks and sending messages without batteries. In contrast, those in Pittsburgh could communicate with New York. Fast forward to modern times. There are concerns about another potentially devastating solar storm in 2025. With our heavy reliance on technology and electricity, the impact could be catastrophic. A Carrington-level event could disrupt power for up to 40 million people in the US alone for years and cause trillions in damages. What are solar flares? They're massive explosions in our solar system caused by the sun's magnetic energy. When these electromagnetic waves hit Earth, they cause phenomena like the auroras, but also disrupt satellite operations and power grids. Case in point, in 1989, Quebec experienced a 12-hour blackout due to a solar flare. And in 2022, a solar storm sent 40 Starlink mini-satellites crashing out of orbit. The sun doesn't only emit flares, but also coronal mass ejections, CMEs, enormous bubbles filled with plasma. Both emit radiation and particles that can overload our power systems and have frequencies much higher than our usual electrical devices. If a storm of the Carrington magnitude were to strike again, it might take up to a decade for us to recover. These solar events can damage satellites, disrupting communications, including the internet, TV, and GPS. The radiation could have lasting effects on our DNA, particularly hazardous for astronauts in space. By 2025, it's hoped we'll be better prepared. Maybe a brief internet break wouldn't be too bad after all. Moreover, it is important to understand the potential risks posed by solar storms and to work proactively to mitigate their impact. The Carrington event in 1859 showed that even the most advanced technologies of the time, like the telegraph system, were vulnerable to solar storms. Today, with our reliance on complex electronic systems and the interconnectedness of our global economy, the stakes are even higher. One way to protect against potential solar storm impacts is to develop technologies that are resilient to the effects of solar radiation. Researchers are working on new materials and technologies that can shield electronic components from the harmful effects of solar radiation. Satellites and spacecraft can be designed with radiation-hardened components to withstand solar storms. Power grids can be fortified to minimize the risk of large-scale outages. Another important step is to improve our ability to forecast solar storms. Current models for predicting solar activity are based on observations of sunspots and solar flares, but these methods only provide short-term forecasts. New methods that rely on a combination of ground-based and space-based observations as well as computer simulations could provide more accurate and timely predictions of solar storms. This would give us more time to prepare and take action to mitigate their impact. In addition to improving our forecasting capabilities, it is essential to invest in infrastructure that can help us respond to and recover from a major solar storm. This includes backup power systems, alternative communication networks, and stockpiles of essential supplies. With proper planning and preparation, we can minimize the impact of a major solar storm and ensure the continuity of our economy and society. In conclusion, while solar storms can pose significant risks to our modern society, with proper planning, research, and investment in infrastructure, we can mitigate their impact and continue to enjoy the many benefits that the sun provides. The key is to be proactive, to understand the risks, and to be prepared to respond to whatever challenges the sun may throw our way.
Brace yourself. You're about to hear one of the most unusual sounds ever. It's come from space, and it's the sound of two black holes colliding. But first things first. Our ears are designed in a special way, which helps us translate sound waves. But these sound waves become mute once the medium they're traveling through comes to an end. It happens when, for example, the atmosphere of Earth gives way to the vastness and emptiness of the cosmos. At the same time, there are some sound waves that can move even through a vacuum. and we can translate these vacuum-friendly waves into sounds our human ears can hear. That's kind of like radio transmissions work. Over the past few decades, people have sent quite many satellites to the far reaches of the solar system, and even beyond. These spacecraft are equipped with sensors designed to hear such things as radio and plasma waves flowing freely through interplanetary space. These instruments are crucial for research and communication reasons. An additional bonus is that now we can finally hear different kinds of space waves as audible sounds. The results are often ear-splitting sounds, and sometimes audios are downright scary. Usually, when two black holes collide, they don't produce a sound. And still, thanks to modern technologies, we can now listen to this terrifying cosmic event. Do you hear it? This chirping sound is the sound that two black holes produced while slamming into each other around 1 billion light-years away from our planet. Interestingly, the tone of the sound rises when the holes spiral closer to each other and stops abruptly when they eventually merge. Now, do you hear that long, low buildup? It means that the merger is quite slow, more sedate, and the black holes taking part in this event are relatively lightweight. A more abrupt chirp is a sign of a fast merger, where the black holes are rather large. For example, the pair that produced this sound combined and created one black hole more than 80 times the mass of the Sun. Since each of these black holes weighed as much as several stars, they were hefty enough to produce waves while passing through space. I mean gravitational waves. They are undulations in the fabric of space-time, fanning outward at the speed of light. You can probably compare them to the ripples that appear on the surface of a pond after you throw a rock in the water. Naturally, the sound of black holes colliding isn't the only unusual noise recorded by our equipment. NASA's Juno probe passes by Jupiter every few weeks at a speed of up to 130 miles per hour and plows through all kinds of invisible fields in the process. And one of the most powerful signals it has recorded is Jupiter's bow shock. That's the point where the planet's magnetic field pushes against the incoming wind of solar particles. The sound produced during this standoff sounds similar to a sonic boom. Or this sound. It was produced by the Stardust space probe when it was passing through the dust left by Comet Tempel 1. In the process, debris hit the body of the spacecraft. It sounded as if some creature was rapping at the window or hurrying across a hard floor. Let's have a look at NASA's nuclear-powered Cassini spaceship. It spent 13 years exploring gas giant Saturn and its numerous potentially habitable moons. This mysterious and a bit spooky sound is actually radio waves emitted by the massive planet. Such waves are caused by a phenomenon which is similar to the one producing auroras on Earth. Speaking of our own planet, it's surrounded by plasma. It consists of hot, ionized particles generated by sunlight. They're constantly slamming into Earth's atmosphere. NASA's Polar mission, which was launched a few decades ago, managed to record this breath-like hiss. That's what plasma orbiting our planet sounds like. As for these weird sounds, NASA doesn't say which space probe recorded them, but they're coming from Jupiter's largest moon, Ganymede. It could have been the Galileo spacecraft, which orbited the system for around 8 years. But it probably doesn't matter so much. Just listen to this creepy noise that sounds like screams trying to break through from some hidden place. Without knowing languages, people from different countries won't be able to communicate with one another efficiently. And imagine if some extraterrestrial civilization sent a message to Earth. How would we figure out their intentions? Like, do they want to get to know us better? Or is it a warning about a full-scale intrusion? It must be terribly hard to bridge the gap between us and creatures whose minds, bodies, and habitats are totally different from ours. So, to practice decoding potential extraterrestrial messages, an artist-led group created a mock message from stars. It was the most alien missive the world had ever seen. Even though it was written for humans by humans, it was as non-human as possible. The message was sent from Mars to Earth, and 3 observatories detected the transmission 16 minutes later. Unfortunately, so far, no one has deciphered the message, but many have been trying to do it. There are only 3 people in the world who know what the message means. One of them is the project's founder, Daniela de Paulus. She and 2 other co-authors created the message after consulting with scientists, poets, programmers, and philosophers from all over the world. The main challenge for them was to get rid of anthropocentricity to make the message as realistically alien as possible. So the team immediately ruled out any kind of language-based communication. Even though now they refuse to confirm or deny that the message contains text. The creators were also considering using mathematics. Yes, the fundamental concepts of this science are universal, but different cultures may represent math differently. De Paulus and her team struggled to compose the message for years, experiencing massive writer's block. But eventually, in 2019, the idea was formed. 3 years later, in 2022, a major breakthrough occurred when the team drew inspiration from a short story called A Sing in Space. And a month before the transmission, an astronomer joined the team, adding a mathematical touch to the message to make it more universal. Since the first announcement, the project has attracted loads of puzzle lovers. They started to exchange ideas, hoping to solve the mystery. Some of them were among the first people to extract the raw message from the ExoMars orbiter's broadcast. It was a 40-gigabyte string of numbers interwoven with the alien message. If it had been real, it would have arrived unannounced, of course. But in this case, the signal came at a precisely scheduled time. Now imagine peeling layers off an onion. That's what filtering the data segment looked like. But after a week's effort, the enthusiasts received an image of 5 speckled clusters against a blank background. After that, the speculation on the meaning of this picture started. Could the message be hinting at the alien's appearance? Was it Morse code? Maybe it hid some genetic secrets? One user even enlisted ChatGPT to help decipher the message. There was also a theory that the image was a star map with the location of the alien civilization. Another suggested that the dots resembling constellations could be molecules. Probably, they were part of the biosignature of the foreign world. But decryption is the process of making sense of some message for which only the intended recipient has a key. That's why this kind of code breaking is much more difficult than decoding, because you need to guess the missing key. Another tricky part is where to start. Every attempt feels like a stab in the dark. You might believe that you have started to see patterns, but you need to stop and think whether it's true or you're just projecting. The community is still trying to decode the message. At the moment, there are more than 30 ideas for how to do it. Only after that can people try to understand its full meaning. How about you? Would you like to try and take part in the process? Maybe you've got some idea? Then share them with us.